What I'm going to be describing now is going to be Ampere's law. And we're going to use Ampere's law to determine the amount of magnetic field, the magnitude of that magnetic field, a certain distance away from a current carrying wire. Now remember that current carrying wire is going to produce a magnetic field. Not R, but the blue dot in the center here is going to represent the current carrying wire. And we're going to measure from some distance from that wire the strength of the magnetic field. Now because the wire is circular, by symmetry, the magnetic field is also going to be circular as well. So what we want to do is we're going to want to write Ampere's law. And Ampere's law is the summation of the strength of the individual magnetic field of some distance around this circle times the cosine of phi. Now the angle phi is going to be the angle between the magnetic field and the length that we choose. Now if they're going to be parallel, phi is going to be equal to 0 and the cosine of 0 is equal to 1. And so now our Ampere's law becomes just the sum of the individual units or the individual magnetic fields around and over that increment of length around the circle. Now the length around the circle is going to be our circumference. The circumference around this ring is equal to 2 pi r. We can then substitute that in for L, and this is going to be a length all the way around. We can sum up all the individual B fields, and that's just going to be B. So now this equation, once we substitute it into there, becomes B, which is the total or the sum of the magnetic field around this ring, 2 pi r. Now if we go back to Ampere's law is equal to mu naught I, where mu is going to be the permeability of free space, I is going to be the current. If we solve this for B, the total magnetic field is going to be equal to mu naught I upon 2 pi r, which is what we've seen before. We've seen this equation before. So this tells us that Ampere's law works great if we're looking, or if we want to determine a magnetic field from a current carrying wire. All right. If you have any questions about this, please let me know.